recording yet, Dirk? Hi, I'm Jason Phelps. Welcome to another episode of Nerd Lab. So a lot of people would like to think that these bugle tubes are just plastic, put together with no rhyme or reason. But we're gonna explain today some of the science, some of the thought that we put into designing new bugle tubes has served a purpose. So as we set out to design what we're calling the Unleashed V2, we had a set of goals. We have to be able to accomplish these, and then we have some requirements. So the first goal is we wanted a value add. We wanted to be able to provide EZ Bugler mouthpieces, which up to now is only available in our metal bugle tube. We wanted to also include the flared mouthpiece so people can continue to use diaphragms. And we also wanted to add a neoprene sleeve with lanyard, and we'll talk a little bit more about why neoprene is important to us. We wanted this tube, our Unleashed, our Renegade, were bigger bugle tubes. We wanted to be able to come up with something smaller than that Unleashed and Renegade was our first goal. We wanted it to be quieter, which we accomplished through the neoprene sleeve, but it also has to be able to be loud enough and hit the tones while the neoprene sleeve's on it. So we worked with our supplier. We couldn't use the same thick neoprene sleeve that's on the metal tube, but we were able to find a compromise on a thinner neoprene sleeve, which does quiet the plastic tube down. We wanted to improve our packaging. One thing is you walk down the aisle of bugle tube aisle, we just wanted to stand apart. We wanted to be more secure as we ship. Nerd Lab. This is really good packaging. I'd like to give Dirk all the credit because he came up with this idea because everything else was expensive, but nope, Dirk came through and said we should put that in a box. Put the round bugle tube in a box. If you want to see how to use the EZ Bugler, all about the V2 Unleashed bugle tube, scan this. And it's going to take you to a website, I believe. Nerd Lab. We got our new Unleashed V2 bugle tube logo on the other side. Neoprene sleeve, pretty quiet. We've got an integrated 1/8 inch shot cord lanyard that's sewn into the cover. The whole thing it's just clean looking.
You know what else is clean? Top of your head is shiny. It's overexposed.
So there are some things that are required on a bugle tube. We can't compromise on sound quality. We need it to produce the resonant frequencies to give us that deep guttural sound that elk produce. We also need to be able to hit frequencies that elk naturally have in their vocalization. So we're trying to get up to that 1800, 1900 hertz frequency to really let that call ring and reach distance. We need the volume. So going to a smaller tube, we needed to make sure that this produces the same, if not more volume than our bigger tube. We needed to create back pressure. The back pressure allows the user to put less air across their diaphragm, which allows your diaphragms to last longer, which just makes it easier to use to create the same volume and the same sound quality. And then this tube itself, what you see here is 100% made in the USA through blow molding. So this part here, we were able to finally find a molder that can do that for us, and super stoked to have that made in the USA. So on a bugle tube, I would say there's two different zones. You have your velocity zone, which is where you blow into the call. The material that this is made out of, from basically the larger area back, doesn't matter. You can have that made out of wood, you can have it made out of aluminum, even our metal bugle tube, acrylic, wood. It does not matter what's back here. This material is basically useless as far as material and sound quality goes. All you're doing here is accelerating air into what we would call like the resonant zone. And a lot of people will ask, well, we used to use plastic baseball bats in the past, and that worked, and why are you adding all these? The only thing you had to control the back pressure on a straight walled bat is the exit hole. That was the only thing creating any back pressure, a little bit of eddy here, and that was all.
Wow. Is anybody else getting this? I mean, I think I'm about to fall asleep. I'm trying to edit this the best I can, but this is like a real yawn fest. I think he's just talking because he likes to hear himself talk. I feel like he just wants everybody to feel like that he's smarter than them. I don't know. I mean, it's an elk bugle. I mean, how complicated could it be?
The inside of our tube is 3 1/4 inches at the big section, which gives us an area of 8.3 square inches. The smaller section, where you can see these depressions, it bumps all the way down to 2.75 inches ID, which then gets you down to 5.94 inches. That's a pretty drastic reduction in area, which is very important to why this tube works the way it does. It's about half the size of the original Unleashed. Nerd Lab. So if we went to the Bernoulli equation and figured out what the heck's going on.
Any point within this tube, if we consider it a closed system and we consider the air is the same within the whole system, we can really start to reduce this long equation down to something that makes more sense. So if we assume that the height's the same from end to end, we can get rid of all of this because we're not changing heights. If we assume that the air stays the same, we can get rid of the characteristics on the air. So really what we have is a pressure plus a velocity of that air equals the pressure plus the velocity of the air in somewhere else. So basically if we reduce all that down, as the area goes up, the velocity goes down. As the area goes down, the velocity goes up. And then your pressure difference is affected by frictional loss within the tube.
So then we're going to jump over to a different equation that can baffle your mind, is the Reynolds equation, which talks about laminar flow. Like if you've got a perfectly smooth glass or plastic pipe, if you had no obstructions, that the air, the water, whatever your fluid is, wants to move through the tube, and its highest velocity is in the center of the tube, and then you've got some coefficient of friction along the edge. So your velocity curve looks something like this on a smooth pipe. On a rough pipe, you start to get
Today, Junior. Oh, my Lanta. Is he ever gonna quit talking about all this nerd stuff? Come on, just show us. What's it sound like? Does it sound like a real elk? Does it sound like a moo cow? What's it sound like? Does it sound like a flute? Come on, Jason. Just let's hurry up to the end. Come on, buddy.
We are designing this for complete turbulence. We do not want anything, a Reynolds number of 0 to 2,000 is considered laminar flow. That's going to flow really smooth. 2,000 to 4,000 Reynolds number is more of your transition where you're starting to, and we want to be as high above 4,000 as we can on that Reynolds number. We want a ton of disruption. So if you imagine the air is flowing down a smooth section of the tube like we showed above, your velocity curve is going this way, and all of a sudden this air hits a hard edge or a depression or something disrupting it, you get these eddy currents, and now you get this air to slow down more like the rough, and it really kind of backs up. On the backside, when that air, so as we mentioned before, your area goes up, your velocity is down, your velocity has to speed up through here, but you're now providing these disruptions from eddy currents, and then on the backside you start to get these separation zones. So it's kind of a combination of all of these things as we set forth to design these tubes, but it is, it's relatively simple physics, but there is a lot of fluid dynamics, physics, and everything that go into this tube to make it as functional as it is. This was the original one we designed, had it 3D printed, we're able to test it, and there's a lot of math and stuff that goes into it, but we also need it to translate into real world results. And when I got this, I was blown away. Crazy volume, crazy resonance, just very, very responsive. It's everything you could ask, and we were able to do it in a tube that's half the size and quite a bit lighter than our bigger plastic tube. So really stoked, and able to add our EZ Bugler and flared mouthpieces on, all for a price that I feel like we're given a great value in bugle tubes. So it's Unleashed V2, complete bugling system. EZ Bugler, if you're still learning to run a diaphragm, we give you your flared mouthpiece in case you want to continue to try running a diaphragm, and then a tube that makes learning to call easier than anything I've ever used. Great back pressure, easier to run. It's going to make you more confident in running diaphragms right off the bat. Check it out, Unleashed V2. I think we hit this one out of the park, and we did it all through science.
That one turned out pretty good.
So we got the new Unleashed V2 versus the original Unleashed, I guess V1 at this point.